I'm sorry, like again it got like disconnected because I'm having a software issue, which is like if it exceeds more than like I'm using a free trial of the software. So if it exceeds more than like some amount of minutes, let's say 35 minutes, 40 minutes, whatever it is, so it tends to like it is like limited to that amount. And after that I need to like do it again, like I need to do the next portion in some other video. So bear with me. So what I was saying that this is actually sorry, I actually mistakenly draw the benzene ring there. There shouldn't be any benzene rings there. I'm really sorry. There shouldn't be any benzene ring. So I'll be doing the correction in the other video in the first part of this today's lecture. So there shouldn't be a benzene ring because this is a hexagon. No benzene ring will be there. Now this is actually a cycloalkane, you can say. Okay, this is a cycloalkane because sorry, this is a cycloalkane, you can say, because there is this like connection, like it sort of like reconnects itself. Okay, so a cycle is being formed. That's why a cyclohexane, you can say. Now this is our hydrogen, half H2. Yeah. Now over here, when we add sodium hydroxide, now there's this thing, it doesn't react because alcohol is not acidic. This is not acidic. This is just simply an alcohol, and due to some like ionization formation, like it sort of dissociates. Hydrogen can get eliminated. That's why this sodium tends to form bond with oxygen. But sodium hydroxide is itself like alkali. Okay, that's why it does not react with this non-acidic solution. Like this is a non-acidic compound. This is not acidic, so no reaction happens. Reaction. Okay, so they can confuse you in this way. Now let's continue with our examples. Now let's say some transformations. Let's see about some transformations. Transformation, like what sort of transformation are we going to learn? Let's say we have this C2H4. Okay, we have this C2H4. They have given you, let's say, a list of the reaction, and they're asking you to give the condition, write the conditions. Okay, C2H5Cl. These are the transformations being happening. I mean, these are the reactants and these are the products being formed. So by applying what sort of reagents or conditions we can get those products, that's what they are asking you. C2H5Cl. Then in number 3 we have C2H6 to C2H5Cl. Number 4 we have C2H4 towards C2H4Cl2. Number 5 we have CH3COOH towards CH3COCl. And number 6 we have CH3 towards CH3. Simply they're giving you all the possible products now, and they're asking you to write the like conditions and reagents. CH3, from there we are getting this. Okay, try it by yourself, pause the video. If you can't do it, then I'll be actually helping, so don't worry. Okay, so what are the reagents? So writing here beside, let's say, the reagents plus conditions. Okay, so for this reactions, the reagents and the conditions. So in the first reaction, we're having what? C2H4 to C2H5Cl. For simplicity, you can also try to draw the like, structured formula or discrete formula. From here, we're getting something like this. Okay, we can actually see this is an alkene. From alkene, we're getting this sort of molecule. That means what? This is an addition reaction, isn't it? This is an addition reaction. And what sort of addition reaction? So alkene undergoes addition reaction, which are known as what sort of addition reaction? Remember, those are known as electrophilic addition. Now, what are electrophiles? Electrophiles are those which tends to like gain electron, or which are like positive, like which have a deficiency in electron, okay, electrophile. And nucleophiles are those which tend to donate electron or which have a surplus of electron, like excess of electron, and the electrophiles have less number of electrons, so they can gain electron. So this is HCl, the condition, the reagents and condition HCl plus room temperature, okay, no other special condition. So let's say beside I'm writing no, nothing special, like no special condition, okay, no special condition. You don't need to write it, just for simplicity I have written. So this is known as, like, this is which reaction. So you can also like write it beside. They didn't want you to write the like what type of reaction is it, but for your learning you can write it that this is actually electrophilic substitution, addition, electrophilic addition, okay. Now in the second reaction we are seeing that C2H5 to C2H5Cl. This is what type of reaction? This is an alcohol and now we have halogen-alkane. The alcohol group is being displaced. That means this is actually a nucleophilic substitution, or we can say PCl5. Simply we can do this one, PCl5. It is not actually nucleophilic substitution. This is simply just a normal reaction, PCl5 with room temperature. Remember, we can add, we can add PCl5 which like at room temperature with alcohol. You can see it in your AS notes, AS contents, that when we add PCl5 with alcohol, that OH group is displaced. So same thing happens here, OH group gets displaced. Now in the third reaction, this doesn't have any specific name or convention, so because we don't have any detailed structure, detailed mechanism for the reaction, so it's better to like not know, because I also don't know about like that specific reaction. So yeah, that's basically it. Now in this reaction, what is happening? We have C2H6. This is an alkane. Yeah, this is an alkane. This is an alkane. C2H6. From there, we are getting what? One of the hydrogen is displayed with chlorine. So what sort of reaction is happening here? Remember, this is free radical substitution. Free radical substitution of alkane, radical substitution. So we can add Cl2 plus UV. This will be the reaction. Number 4, we're getting, this is an what? Alcohol. This is an alkene, C2H4. From there, we're getting C2H4Cl2. This is also another electrophilic addition, Cl2 at room temperature. Okay, no special condition. If in alkene, whatever reagents we add, and like for free radical addition for alkene, we don't need any special condition. Like in room temperature, if you provide them, they are like happy to react. Okay, so they're happy to react. Now CH3 COOH. From there we are getting what? This is an carboxylic acid and we are getting an acyl chloride. Remember, how do we get an acyl chloride? We simply need to add like the source of chlorine. So it could be PCl5 or SCl2. So 5 number, which is PCl5, let's say it is PCl5 at room temperature. So here also no special condition. Okay, so PCl5 adding the acyl chloride is being formed from carboxylic acid. This is also given in your AS notes. This is also given in AS notes, and this is also given in AS notes. Yeah, these are all AS contents. The like above 5s are all AS contents. Then we have what? We have number 6, which is benzene, and we can see over here benzene. We don't have anything to the left side, but we have a chlorine here. That means what? This is actually electrophilic substitution, but in electrophilic substitution, we learned 2 types of reaction. One was Friedel-Crafts alkylation. Another was where we added the reagent what? Cl2 plus FeCl3. Remember? So here's the thing. When we add pure chlorine, okay, no alkyl, like halogen alkane, let's say CH3Cl. This is the halogen alkane. When we need to add halogen alkane, we add the AlCl3. Okay, but when we add pure chlorine, let's say, then we add what? FeCl3. Okay, so that's actually the basic cases. This doesn't have any specific name, but this is the type of reaction is what? Electrophilic substitution reaction. You also can write it beside. This is actually an electrophilic substitution reaction. electrophilic. Okay, and this is electrophilic addition. Electro addition, I'm writing in short, so electrophilic addition. Now in the last reaction, we are having what? CH3 to CH2Cl. This is actually reaction in what? Side chain, like I mean the chain react, like on the side chain of the benzene molecule. So no benzene molecule is involved in this case. So side chain reaction, and one of the hydrogen is displayed by chlorine. In this case also free radical substitution, remember? So this should also be Cl2 plus UV, okay? So these are the type of reactions in this case. Let's move on to next example. In this case, let's say we are having CH3 and we are having, let's say, H plus. This is H plus, and we added, let's say, MnO4 minus, and it hit. So they can also give you it in this way, H plus, MnO4 minus. Like I just wrote it for the simplicity together, okay? So this is H plus with manganese. This is actually what? Oxidizing agent. So they are telling you that this sort of product is being formed. And from there, when the product, when we add Br2 with FeBr3 and hydrous, the reaction should be. Oh, I forgot to mention that in the previous reaction where we added in the 6th number reaction, the reagent for 6th number reaction, which we added Cl2 with FeCl3, isn't it? The FeCl3 should also be anhydrous. Okay. Now over here, we're getting this product. This is COOH, and this is Br. Okay. So try to guess what reaction could have been happening. Wait, this is a mistake here. COOH, yeah, this is now perfect. So here is happening that, try it by yourself, because I'll be showing it right now. This is an oxidizing agent, and for benzene, when oxidation happens, what happens? The side chain actually transfers into carboxylic acid. So benzanoic acid is being formed, and from here, when bromine is added, see, there I have done the rest of the work. So this is actually a very simple one. So let's do the next one, which is, they have given you a series of substances with possible, let's say, this is sodium. They have asked you to write the, they have asked you to write the, what is happening? Yeah. Okay, so they have asked you to write the condition there as well as the product. Why is it doing like this? I don't know. So why is this auto correcting itself? I don't know. So bear with me. I'm not sure what is happening. So with this benzene, like just saying what sort of reaction can occur with phenol, are they asking you, and you need to write the condition as well as the product. Let's say this is also the phenol. We are having in this case CH3 COOH. What can with, I mean, what are the reaction and what can be formed, and finally another phenol, and we have Br2. What what is the product it can form and at what conditions? Try it by yourself. Also remember, in some reaction there can be no reaction. Okay, there can happen no reaction. So do it by yourself. Try it by yourself. If you can't, because I'm going to do it right now. So even if you can't, it's completely fine. So watch and learn. So when phenol, we know phenol is acidic. When it reacts with, like how it reacts with sodium, it reacts with sodium to form what? This ONA plus minus. Okay. And the condition is what? Actually no condition. So we can say either we can say RTP, or we can say no special condition or nothing special. Okay, nothing special. You'll see in mark scheme they tend to write nothing special or no reaction or room temperature. Either is correct. Okay. Now in the second reaction, sodium hydroxide and the phenol, they're reacting. Obviously, they're going to react acidic and basic characteristic. So again, the same concept, Na plus and O minus. And here also room temperature or no special condition. In the next reaction, we are getting what? This is a carboxylic acid and this is a phenol. Both are acidic. That means what? Acid cannot react with an acidic molecule, so no reaction. Okay. Reaction. What is happening? I don't know. No reaction. Okay, yeah. So here also we can say nothing special or we can say RTP because they are meant, like it is mandatory for you to write it. This contains 1 mark. Like you didn't provide any special condition and nothing actually happened. Now in the last reaction, what is happening? We have, sorry, this is Br2. We have phenol and bromine. We know what this is used as an identification reaction of phenol, where phenol reacts with bromine to form white precipitate. Remember, you can see the phenol topic. So Br, and there is Br, and this happens what in aqueous. So I know these conditions are a bit weird, but these are the conditions which are like specifically given in mark scheme. So I have nothing to do. I used to also write room temperature, but I used to get like deduced marks. So yeah, I hope inshallah you won't make mistakes. So learn from my mistakes. Now let's continue. We have the next example where, let's say this is our molecule OH. This is our OH plus. What is happening with you? Why are you behaving weirdly? Yeah, so now over here, when we add, let's say, concentrated HNO3, concentrated H2SO4 at 55 degrees centigrade, we know actually now in this case, like up until now, we actually got to know actually what sort of reaction is happening here. Then when we add SN plus concentrated HCl with some heat, we also know this, who can form this molecule, isn't it? We know. Now, when we are CH3COCl, we get this molecule. There's an interesting information I'll be sharing after we solve this question. This is OH, and we are having here NHCOCH3. Okay, so now let's see what is happening. We have condition for what? Nitration of benzene, but what molecule is given here? Phenol. You can try it by yourself. At first, try it by yourself. Do make mistakes. It's completely fine because if you make mistakes, you'll learn more. So this is phenol, but benzene, like nitration of benzene's conditions are given. So what is going to happen? Simply nitration of benzene is going to happen because like we have phenol in the, like, see the next reaction, like the product after this reaction. Okay, this one, take help from this. What happened? This is actually condition for what? Formation of phenylamine from nitrobenzene. This is the phenyl, like this is the phenylamine. That means phenol remained intact. Phenol didn't change its condition. That means phenol is not going to react. So these are certain things which you can take help from by observing the question. Obviously, in our note, we know that phenol also participate in nitration. But in this case, what we can observe that according to their question or their structures, phenol didn't react. Phenol did nothing. Okay, you don't need to remember here, like the concepts here, but try to make sense that what they did and what they didn't. So based on that, we are going to also answer. So phenol didn't react. Okay, so we are not going to consider phenol in this case. So we are considering this is actually benzene, and nitration of benzene is happening. Now, where is the nitro group being added? See, phenylamine is in this. The amine group is at the bottom carbon. I mean the fourth carbon. So we could also add the nitro group to the first carbon, because from there it will be the step after which, when tin and concentrated hydrochloric acid is added in heat, this phenylamine is formed. And when this phenylamine is added with the CH3COCl, which is an acyl chloride, we get this amide group. Now, the interesting thing which I was going to tell you is, this is the structure of the paracetamol which we tend to eat. So paracetamol. Okay, you can search it on like Google or YouTube. This is actually the structure for paracetamol. So now we become doctors. We become pharmacists. We can produce medicine. Don't attempt what I said, okay? And like I will be in trouble. So we are still not like perfectly like having that sort of qualifications right now. We need to know more. But inshallah, we will be able to like produce, inshallah. So now in the next part, that was the solution for that one. In the next reaction, next example, let's say we have been given this molecule. Remember, whenever they give you the structure of like the benzene structure, the ring, that time it is only benzene. If no ring is given, not a benzene. Don't get confused. From here, we tend to what is happening with you? So let's do one thing. Let's do this. And let's say we have these conditions: hot, concentrated, KMnO4. Before you solve, I'd like to say this is actually a context from AS, so it would be better if you get revision. So the products you need to say. And in this case, in the next case, we have, let's say, this molecule. Again, same conditions: hot, concentrated. Sometimes they would say MnO4, sometimes they would say KMnO4, both are correct, okay? I mean MnO4 minus and KMnO4. This means acidic condition. When H plus is given, that means acidic condition. And you need to write the product in this case. Then we have the third structure. From there, we will be getting OH. And we apply heat, Cr2O72 minus. This is chromate. This is another oxidizing agent. That's another oxidizing agent. Cr2O72 minus is a mild oxidizing agent. That means it has the oxidation power which is a bit weaker, I mean lesser power, while MnO4 minus is much more stronger oxidizing agent. Okay, this is actually a mild oxidizing agent, like a bit milder than MnO4 minus. Now let's try to write the like the reaction. Now there is another example I forgot to, like I didn't have the space to give, so there is a contribution for this one, which we would say, let's say this is the part where, okay, let's draw it off like after this one. Let's solve it first. Try it by yourself, then we do it together. Okay, so hot KMnO4 H plus. Now when we add hot KMnO4 with H plus, if we have a double bond, that tends to break. Okay, this is the contents for AS, where we see that if double bonds are present, now if both the carbon, like since this is the carbon, if both the carbon is bonded with what alkyl group, then that will form a ketone. That will form a ketone. And the carbon which is bonded with one of the one hydrogen and one alkyl group, in this case this carbon is bonded with, let's see, this is bonded with an alkyl group, double bond, and an imaginary hydrogen. Okay, that causes these 4 bonds to be formed. If such molecule, such atom is there, that means that part will form a carboxylic acid. This is going to get broken. Okay, in hot condition, this is going to get broken. The double bond is going to get broken, and this will be the situation. So CH3 COOH. So this is the carboxylic acid for this part, because this carbon is bonded with a hydrogen and alkyl group, and this carbon is bonded with, here is an alkyl, here is an alkyl. I mean, this is an alkyl group, this is an alkyl group. So that will form a ketone. Now in the next condition, we have hot KMnO4, but here we have what? This is a benzene. And we know with benzene, if oxidation reaction happens, then what happens? The side chains disappears and forms carboxylic acid, benzenoic acid. That means completely this will form, not this one, okay? Don't think this will form carboxylic acid. This is not going to be the product. Rather, the full chain will become this. Okay, so I wrote it in the opposite direction, so that's why in this way. So this full is going to get displaced, okay? Remember that. And in the last condition, we have some mild oxidizing agent. Why I mention mild? Because benzene only react with strong oxidizing agent, not mild oxidizing agent. That means in this case, this is not going to perform in the same way as MnO4 minus, I mean this way, like this reaction perform. That means here this Cr2O72 minus is going to perform with these molecules, whatever we have, like it is not going to touch this benzene, okay? Rather than benzene, if there is anything else, it is going to perform. That means if we would have added Cr2O72 minus to this molecule, there would have been no reaction because it won't affect the benzene molecule. But since here we have the alcohol groups, and we know when we have alcohol groups, what happens? Oxidation takes place. And if it is a primary or secondary, carboxylic acid forms. Sorry, yeah, carboxylic acid forms. If it is a tertiary, then what happens? It forms, so tertiary doesn't undergo oxidation reaction. If it is primary, then it undergoes like it forms aldehyde or carboxylic acid. Here it is primary. So that means this will form, actually, in this case, it will form carboxylic acid, COOH. Why C from here? Because this carbon is bonded with this oxygen. So carboxylic acid. And over here, we're having this carbon bonded with this one, bonded with that alkyl group. This is the OH group. That means this alcohol will form this ketone, okay? And tertiary alcohol does not perform any oxidation reaction, okay? So this is basically the structure. If you didn't get it, go through the contents. Again, rewatch this. Again, rewatch this. Watch it again and again. Inshallah, you will get it. Now, the last one, which I mentioned, the continuation of this example was, this was given. And this is cold dilute MnO4 minus with H plus, and we have this product, and when we add Cr2O72 minus and heat not under reflux, that means there is some things they want to say us not under reflux, okay? This actually means a way we can, like, this is my, like, what I'm writing here, this is actually meaning this is actually direct distillation, okay? That means they are not doing that heat under reflux. Heat under reflux means we have this beaker, on that, let's say we have this test tube, and this is the water, okay? They heat the water, and that boil at that, like, hot water, that actually heat up this reaction, okay? That is known as, like, heat under reflux. And heat not under reflux means we are not doing that step. So direct distillation. In this case, what is happening? They're forming this product, CHOOH, okay? Now let's see what can be formed here. From here, we have cold dilute KMnO4. We know when cold dilute KMnO4 is being added, the reaction is, like, the double bond, like, the full structure don't break, just one of the pi bond break, one of the double bond breaks and forms diol. That means one of the bond will break and form this diol, which will be, in this case, this is one of the OH, and here we have another OH, okay? So this will be our structure. Now see that when Cr2O72 minus, this is an oxidizing agent, and we are saying heat not under reflux, that means direct distillation. That means here, at first, see, let's see what type of, like, alcohol these are. This is a what? Tertiary alcohol. That means this will remain unchanged. Tertiary alcohol does not undergo oxidation reaction. This is what? This is a primary alcohol, because this carbon bonded with this alcohol group, then it has an imaginary hydrogen and one alkyl group, okay? So that means this will perform our like oxidation reaction, but two possibilities. If heat not under reflux, in that case it's an aldehyde. If heat under reflux, then carboxylic acid is formed. Since heat not under reflux, that means an aldehyde is formed, which is a CHO group. That's why it is written here wait, this is carbon, and their other two becomes actually our HO group. Okay, so previously it is OH, H, and alkyl group. And anything else? What did we have? What did you miss? Two hydrogen. Yeah, two hydrogen is there. So what happens? This is an alkyl group, let's say. This is our group. When this happens, what happens is this two gets eliminated. Okay, the hydrogen is eliminated, and we're left with this carbon and a single hydrogen and this R. Okay, two of the hydrogen went away, and are left with our aldehyde. Okay, so this is our product. Okay, so that's all for today. See you in the next class.